Okay, we're recording it now. There we go. And that's what we have. Cool. So we have all that. And then pipeline info.layout is pipeline layout. Cool. And then the render path is a render path. Subpath is 0 because we don't have a subpath. Cool. And then VK. So we can use base pipeline, but like we're not going to be doing that. So null. And VK pipeline is graphics pipeline. And then we have if the creation is not a success, throw an error, which checks out. And then we have a graphics pipeline. And cool. VK pipeline graphics. Oh, we had to hold this in our class object. Okay, this is part of the class now. Oh my god, actually insane insane class, because it's like holy pure insanity. Yeah, and then in cleanup above here we go VK destroy pipeline, and the device, the graphics pipeline, and then the allocator, which is just a null pointer because we're just going to use the default allocator. Cool. There we go. And so now we have to run this. Make test. It runs just fine. All of this is good. Hello? Yeah, we're good. Cool. This is a great success. This is a great success. Right? All things considered, amazing success. Now we can go into drawing, which is another... Okay, hold on. Let's actually review how long this is going to take, because this is... Okay, frame buffers. This seems small. This is just create frame buffers. Sure, it's one thing. Command buffers. So we start by creating a command pool. Okay, this seems like it'll be a little bit longer, but it's decent. Rendering. Semaphores, what to choose, creating objects. Subpass. Oh! And this is what happens when we get the triangle. Unfortunately, it starts failing, so we should do stuff. And then frames in flight. And that's it. Okay, so we can do this. This actually seems like it'll be reasonable. So create a standard vector class member. Yes, sir. Where is the class? There we go. Standard vector class member. Standard vector, and it's going to hold VK frame buffers. VK frame buffers, and a swap chain frame buffers. Capital B. No, lowercase b buffers. Buffers. Cool. And then from here, we create a new function called create frame buffers. In create, where is it? Hold on, I'm losing it. I'm losing my mind. I'm going insane. There we go. Create frame buffers. Void create frame buffers. Cool. And so by resizing the container to hold all the frame buffers, so swap chain frame buffers dot. So we resize it to hold all of the frame buffers we want, and then iterate through the image views and create a frame buffer. So we just iterate through all of these, and we just go, all right, we're going to create a frame buffer now. Cool. Okay, I have to go one more indent in. Cool. This is, yeah, cool. So there we go. We have the attachment, which we create. So we create all the frame buffers. We just iterate through it, and we just say, hey, create a frame buffer with the render pass and all that. And in cleanup, we just do VK destroy frame buffer. Cool. This I will write, because this is pretty simple. Oh my god. Actually insane. insane code, right? Like, let's be entirely real. Insane code for range. Auto frame buffer. The range expression is going to be swap chain frame buffers. And in here, VK destroy frame buffer. And so it's going to go device frame buffer and the allocator, which is null pointer, and obviously semicolon. Cool. Let's see if this runs. Yes, it does. Cool. And on to command buffers. So these are the commands you actually send to the graphics card. So they're not executed directly. You record it in a command buffer, and so it's just submitted together, and it's like fast. Cool. Makes sense. Makes sense. VK command pool. Inside the class member, because of course. Yeah. Insane amount of stuff we have to do, but sure. VK command pool. That's going to be called command pool. Cool. So in our init Vulkan, which is actually pretty close to the top, all things considered, I'm going to have a nice create command pool. And so void, Coid, I love Coid, void create command pool. And this should just create a command pool for us. And it only takes 2 parameters. I'm not typing all that out. It's going to take Q families and the command pool info, which is just resetting it, family index, whatever. So 2 possible flags. The command pool create transient bit and reset command buffer bit. So Val's command was re-recorded individually without the flag. They had to reset altogether. That command was re-recorded very often. Okay, cool. We don't particularly care about that. Cool. So it's submitting it. And so if it fails, you know, we fail to create it. This makes sense. This makes a lot of sense. Cool. And in cleanup, VK destroy command pool. Yes. Amazing. Actually insane code this all is. Like, let's be real here. This is truly insane code just to get, like, a triangle rendering. Like, I get that everybody has to do this, but, like, holy. I think from here, what we have to do... Oh, now I have to allocate a command buffer. Cool. VK command buffer as a class object. Here we go. VK command buffer, and this is going to be called command buffer. And create command pool, create command buffer. We're creating all the stuff. Sure. Create command buffer, and then void create command buffer. Cool. And so we have to create command buffer. And this is just another, hey, Vulkan, create this command buffer for us. Go. Honestly, it's getting kind of uninteresting at this point, because it's like, hey, I want to create command buffer. How do you do it? Oh, just call this magic thing, right? Like, it's not super interesting at this point, because we're just rushing towards the triangle at this point, right? All we care about is the triangle. So, yeah. Hold on. So the stream's... Oh, I know exactly what's going on here. Yeah, because I'm running the Vulkan. It's causing issues with my actual streaming stuff. And there we go. Cool. Amazing. So, yeah. Now we just have to keep going here. So level... okay, so what exactly are we saying here? The level is just primary, so it's going to be execution. And secondary is, hey, primary command buffers can call it. So it's helpful to reuse. It's just like function. It's like a function command buffer. Checks out. Cool. Command buffer recording. We start working on record command buffer that we just write stuff to. So, void record command buffer. I'll put it underneath here. What? Hold on. I don't need that semicolon. Cool. Cool. Record command buffer. There we go. And so what I need to do here is I just need to go back here And this just says go ahead, begin info. Hold on. So we start by recording command buffer by calling vk begin command buffer. So this is the begin command buffer info. So this is just like, hey, go ahead. We are going to begin the command buffer. This is the first command. This first command begins the command buffer. Cool. And so we tell it, hey, this is the begin info. We have no flags. I don't care about those bits yet. Starting a render pass. Drawing starts by a render pass with vk command begin render pass. So it's pass some parameters. Begin render pass info. So now this is what we actually care about. So it's we feed it in our render pass and our swap chain frame buffers into our image index, which we're feeding in here. Cool. And so render pass, the render area, the offset, and the extent. We're setting, there's no offset, right? So it's the regular part of the screen. The extent is just swap chain extent, which checks out. And so the next two is, the size. And it's the render area defines where stuff happened. Pixel size will have undefined. It should match the size of attachment for best performance. Makes sense. And so the last two define the clear values to use for VK attachment. Load op clear. So when you clear the screen, what does it do? Sets it as transparent, which checks out because we have all of our images. So we go transparent onto the next one, transparent onto the next one, right? So that makes a lot of sense to me, you know. And VK begin render pass. There we go with the command buffer. Okay, where does this function go? Where are we calling record command buffer? Go to references. It's not being called anywhere, huh? So why did we make takes the commands we want to execute into command buffer? Sure, you know what? I trust it. I trust it. Start a rendering pass. Yes, we did the begin steps. Basic drawing command. So now we bind the graphics pipeline. I assume with the command buffer vk pipeline bind point graphics. And then, okay, so we set a viewport and whatnot. Cool. So it's viewport X and Y is whatever, right? Setting the viewport. Setting the scissor on the command buffer. We're just editing the command buffer. Yeah. Command buffer. We're just modifying this command buffer to like insanity. And then we do a draw command. Wow, there we go. Command buffer. VK draw. Sure. So it's a bit yeah. Climatic, but it's so simple because of the information that we specified in advance, which is all of the other stuff. So vertex count, even though we don't have a vertex number, 3 vertices, yep. Used for instance rendering, so 1 if you're not doing instance rendering. First vertex, it's the startest one, and the first instance is the starting one. Cool. The render pass can now be ended. VK end render pass. And if it's not done, just throw an error. So we say, hey, that's a render pass. Cool, there we go. So that's kind of all we need to do. And yeah, so from here we just let's run it, see if hello. Yeah, okay, my terminal's going fine. Yep, we still compile, we still run. Everything's all good, everything's all good. So now we keep going. So rendering and presentation. This is where we get our very nice triangle, right? Yes, so we do get a triangle here. Cool. So a whole lot of stuff has to happen. So the main chapter, everything's going to complete. We're going to write the draw frame function that will be called for main loop to put the triangle on screen. So create the function, call for main loop. Okay, got it. So we just scroll all the way down to our main loop. This is insane project. Main loop. So in GLSW poll events, draw frame. Cool. And underneath, void draw frame. And yep, there we go. And now what are we putting in the frame? So high level overview. Wait for the previous one to finish. Acquire an image from the swap chain. Record a command buffer, which draws the scene onto the image. Submit the recorded command buffer and then present it. Okay. That makes a lot of sense. That makes a lot of sense, actually. Cool. So synchronization. So synchronization is explicit. Order of operations is up to us. So this is just, we have a lot of control. So we're creating semaphores to add order. So it's like, oh, wait for one to finish. So we have a command buffer A and B, and then we create a semaphore. So in QA, signal S when done, start executing immediately. So work A, signal S, wait done. And then in Q is work on B, wait S. So we set a Q, and then when this one is done, it emits a signal, and then this one waits until that signal comes through. Makes sense. Cool. So a fence has a similar purpose, but it's used to synchronize execution. So ordering the execution on the CPU, so the host needs to know when a GPU okay, so the fence, so the signal operates exclusively on the GPU, and then the fence operates on the CPU, right? So this makes a lot of sense actually, all things considered. Cool. So the pseudocode, we have command buffer and we have a fence. VK submit it and then wait for fence. So we block the main thread and we like save the screenshot, whatever. We do whatever. So this example does block host execution. So you don't block the host until necessary. You want to feed the GPU. And so while you're waiting, do other stuff. Waiting on fences signal for not used for work. So they prefer semaphores, which don't block the CPU, which makes sense. Wish to choose, swap chain, and waiting for, so they want to use semaphores because they happen on GPU and they want to make sure the host. Cool. So creating the synchronization object. 3 class ones, 2 semaphores and a fence. Okay, sure. I assume, oh my god. Cool. So image available semaphore and render finish semaphore. So image available, I assume is so we make an image and then it's ready, and render finish is like, hey, actually do the rendering. And in Vulkan, we have to create a sync objects. Oh, hold on, in Vulkan is, I believe, above. Hold on 1 second. Cool, we're back. There we go. Underneath, it's create sync objects. Yep. Create sync objects. And then void create sync objects. Cool. And so creating a semaphore is required, but the conversion doesn't have any fields inside S type. So it's just, hey, we're creating a semaphore. This is semaphore. Use it as a semaphore. Checks out. So future Vulkans may add functionality for the flags in pnext, like it does for other structures. Creating a fence requires filling in the fence creation info. Okay, sure. This is just, hey, we create a fence. Cool. Amazing stuff. And then we create all 3, and if any of them fail, you say, hey, we failed to create our semaphores or fences or whatever. Which, sure. Easiest. This is all logically simple. There's just so much verbosity here that's actually kind of insane, right? And then in cleanup, we destroy all 3. Sure. As you can tell, I'm getting actually kind of impatient because I'm waiting for I want the triangle, you know? Where's our cleanup function? There's a cleanup function. Cool. Amazing. And there we go. Waiting for the previous frame. At the start of the frame, we want to wait until the previous frame is finished, so the command buffer and semaphores are available to use. To pull out, we call VK wait for fences. So in draw frame, so we VK wait for fences, and so we go device fence count 1 fence. A pointer to our fences is going to be, it's a reference to in-flight fence. Wait all is true. So we wait until all of the fences, we have 1, so it doesn't actually particularly matter. And our timeout is uint 64 max. So it's all 1s. There we go. So it takes the array and waits for either any or all. True, we're gonna wait for all, but in this case it doesn't matter. Cool. So after waiting, we manually reset the fence to the unsignaled state with the reset fences. Checks out. So we're saying, hey, we did in fact see it. And before we can proceed, there's a slight hiccup on the first frame. They call draw frame, which immediately waits. It's only signaled after the frame is finished, but it's a French. Since it's the first frame, we don't know what's going on, right? So that makes sense. And so it will never happen. And so one of the many solutions, clever workaround, create the fence in the signal state. So the first call returns immediately since it's already signaled. That makes sense. So we just say the previous frame has rendered for the first frame, which makes sense. I just have to scroll up all the way to it. Create sync objects. Yes. Fence create info. fence info dot flags is going to be equal to vk fence create signal bit. Cool. So it is done. And then we need to get an image from the swap chain. So all the way back down to our very nice draw frame function. Yep. Draw frame. uint32 type is image index. So the index into our swap chain. And then vk acquire next image khr. vk acquire next image chronos. The device is device. Swap chain is our swap chain. The timeout is uint64 max. uint64 max. The semaphore that we are going to be doing here is the image available semaphore. The fence that we're looking for is vk null handle. Okay. That's a closing parentheses. vk null handle. And the pointer to the image index is, oh my god, where's my mouse? There's my mouse. And it's appointed to our image index. Reference to image index. Cool. I'm going to move it down below here. Swap chain. Oh, capital C swap chain. There we go. Cool. Oh my god, I have caps lock on. I don't know why caps lock is next to A. That's like the most annoying thing, you know? Like, why are they doing this type of stuff? Cool. Create an image from the swap chain. Yup. Recorded the command buffer. So now we vk reset command buffer. vk reset command buffer. And so we're going to feed it in our command buffer. And the flags is there's no flags on our reset. So we're resetting everything. Cool. And then we're going to run our record command buffer. Record command buffer onto our command buffer. And the image index is going to be just our image index. Oh, we need a semicolon. There we go. Cool. Submitting the command buffer. So queue submission synchronization is configured to parameters in vk submit info. So I am not going to type all that out. I'm going to be entirely real. I know I would have, but like we're so close to the end that looks like I wanted the triangle. So wait semaphores is image available. Wait stages is the color attachment bit. Wait semaphore count. We're only waiting for one of them. Yep. So the first three parameters specify which semaphores to wait on, and yep, and then which execution, whatever. Submit the buffer count and command buffer. So this is the buffer that we're going to be submitting to. Cool. That makes sense. That makes sense. And then from here, what we're going to do is we have a semaphore, signal semaphore for just a signal for when we're done rendering. So this is our semaphores that we wait for. This is our semaphores that we're signaling when we're actually done. And then we submit the queue. This should be our render. Hopefully. Subpass dependencies. Oh dear god, how much? Oh, we're close. We're so close. We're so close. Just subpass dependencies and presentation left. Okay, we're so close here. We are so incredibly close. So, what are our dependencies? So, go to render create struct. Hold on. What? Hold on. Where is this going? So, dependencies in vk subpass dependency struct. Go to create render pass function and add one. So, oh boy, it's. Let's just go up to our, hold on, that's a graphics pipeline, shader module, create render pass function. So at the bottom of our render pass function, we're going to create a dependency. Okay. Cool. So dependency and the, like we're just creating a dependency. And a dependency dot stage mask. So it's a dependency on the stage color attachment output bit, and the access mask is 0. And so we're just setting up more destination stage access mask. So we're just saying, hey, when can you read and write to it? And then render pass dot dependency. Okay. Hold on. So this we have to move up. Let's create it down here. Render pass info. Yep. There we go. Cool. And so now what we have to do is we just have to keep going here. We just have to keep going. And so Again, I think we're almost done. Presentation. Last step. We go back to draw. Hold on. Let's make sure that this actually compiles. Okay, we're good. We're good. And so now we go into draw frame. Oh my god. My page down button is going to die after all of this. Like, let's be entirely real. Where is it? There is the draw frame. Beautiful, beautiful draw frame. In here, we have a present info. So we have the stuff. Right? So, S type. The wait semaphore is just we're waiting for rendering to be done on the graphics card. And so we have our swap chains. Right? So we get our swap chains here. And well, our swap chain, we only have one. We set the present info dot pointer to our results to be empty, and then we present it. Well, what did I mean? Present queue. Sure. It's not doing. Oh. Let's hold on. Let's go to the make file. Let's. Okay, hold on. Make Vulkan test. Hold on. Let's make sure this works. Let's make sure this works. Ignore the background noise. My dad is on some call. I don't know. And then make test. Error. Failed to open file. Dang. Hold on. Dang, this is actually unfortunate. We were so close. Now we're in debugging mode. We are in insane debugging mode. Let's go down to let's go down. // first triangle? Yeah, it just failed. Failed to open file. Colon / where colon %sign / failed to open file. If not files, read file. Okay. Why do we... What file are we reading? File name. And then make Vulkan test. It's going. Run it. Shaders / verts.spv. Probably because that doesn't exist. Let me... Oh, I have to chmod it first. Chmod +x. Oh, I should probably change the goal on the stream. That's probably a useful thing. Yeah. Whoops. The goal. First, Vulkan triangle. Cool. Okay, cool. There we go. That's now fixed. I'll make the goal bigger. There we go. There we go. Sorry about that. Sorry about that. Viewers, +x, compile.sh, / compile.sh. There's shaders. Then make Vulkan tests. Make test. There's a triangle. I'm taking a screenshot of this. I'm taking a screenshot of this and posting it to my Twitter. I will not be showing my Twitter live on stream. I will just be posting it. First triangle in Vulkan. And I shall post that. There we go. Amazing. And there's our first triangle. It should be different because this tutorial is shaded in template and linear color space and converts sRGB. Yeah, it looks exactly the same. It looks exactly the same. There you go. Illuminati indeed. This is true. This is true. I do have my first triangle in Vulkan now. I'm getting some very nice screen tearing. I don't know if that shows up on the OBS. I don't think it does, but like on my actual physical screen, I'm getting some screen tearing when I do that. But let's go. First triangle. Can I make this bigger? I cannot change the size of the screen. Hold on. Let's make the screen bigger. Height 800 by 1600. Now let's go 1,000 by 800. Make Vulcan tests. Make test. Big triangle. There we go. Nice and larger. This is true. I did make the Pride Month Vercel logo. Yes, the Vulcan first one is a Pride Month Vercel logo. That's probably a clip that should exist on my YouTube channel for stuff. But yeah, very nice, very nice. Now, obviously, there's still frames in flight. But yeah, unfortunately, you'll see the validation layer is enabled. The program crashes as soon as you close it. The message print from debug callback calls what? Does it? Oh my god, it does crash. Ah! Remember, the operation is draw frame asynchronous, so that means when we exit it, it may still be going on. Cleaning up and resources while it's happening is a bad idea. So they should wait for the logical device to finish before exiting the main loop. Okay. Checks out, checks out. Don't be evil. Though I guess it doesn't particularly matter, but whatever. Where is main loops above this main loop? And then here, VK device wait idle device, a very nice device. Make test. Closing it. It doesn't fully crash. We have a very nice and beautiful triangle. There we go. And in conclusion, little over 900 lines of code. Hold on, let's check that. Well, I believe it, because like almost 1,000 lines of code. I am taking a screenshot of that. I'm taking a screenshot of that, and I am posting also that to my Twitter. First triangle in Vulkan takes almost 1K lines of code. Who thought this was a good API? Cool. There we go. Oh my god, it finally happened. Amazing. Conclusion. Next chapter is expand the render loop to handle multiple frames in flight. Vertex buffers, uniform buffers, texture mappings. Okay, this is slightly insane. Okay, frames in flight. We have frames in flight and whatnot. I think, you know what? I think I'm gonna leave it there. That was a very successful stream, and I'm going to head out now. I will see you all later. Goodbye.